All right, the last part from this problem set is a column, or sorry, the guide block. It does have specialty holes, countersunk, counterbored, and drilled holes to depth. Since there are 4 of them, if we create one feature, we can then run circular pattern from our solids toolbar. For the flange coupling, we looked at doing it with the sketch. Here, since this is a feature that we have to create, we can then run that feature. It's going to ask us for an axis. Well, in this case, you technically don't have the axis that you want. What you do have is this larger diameter hole to reference. If I have a circle, it will reference that. This is how we're going to do it here. Okay. Parts in inches. Specialty holes, 3 different types. We can mirror. If we have this hole, we can mirror this one. Well, if we do both of these, we can mirror 2 features at a time, which is what I'm going to demonstrate. Try to save you some time. Okay. This part is in inches. And I would start with the overall structure, say the base material, but this one's pretty straightforward. We have an overall length of 5. We have an overall height of 2.38, and material thickness is 0.75. And we have an overall width of 2.75. Okay. If I start with this hole in the center, the diameter of this hole is 1.5. Make sure I'm referencing the correct edge. The distance to this center is 2.5, and it is 138 in from the side. And this is just going to get cut. We will use this circle to drive our circular pattern in our features toolbar. Sorry, in our solids toolbar. Pattern, circular pattern. Okay, so first I have to place a hole. So on this surface, I want to create a specialty hole, and this time it's going to be a drilled hole to depth. In terms of reference, if I hover over this center, I will get a, of course not now when I want to show it. All right, we'll play the game. To set that distance, I know that I eventually want to put a hole here. I'm going to use this sketch point as a place of reference. Being that these holes are in a 2.12 diameter, I need to cut that in half to get the radius. Cut it in half. All I'm going to use is this point to place my hole. All right. So drilled hole to depth. The depth is 0.4, 118 degrees, standard drill bit angle, and I have a hole diameter of 0.25. One drilled hole with the drill point angle. I want to now reference this feature. So I'm going to go to circular pattern. What feature do I want to pattern? That is this hole. The axis. I do not have an axis to drive this on. By selecting this axis, I can select this curved surface. Right now I have 3 references. They're equally spaced. I want 4. So solid circular pattern. All right, next specialty hole, counterbore. I have a drill depth. As long as it's going all the way through, I'm just going to put in 1 inch. I have a counterbore diameter, which is the larger diameter at 0.5. Drill point angle is not going to matter. It goes all the way through. And I have a drill diameter of 0.28. Positioning. Reference from the bottom edge is a distance of 0.62, and the distance in from the side is a distance of 0.62. I'm only going to create one of the, how about a counterbore depth? Counterbore depth is 0.25. Okay. Instead of doing that work again, I'm going to eventually mirror this, but I'm going to create this other hole and mirror them both at the same time. So on this top surface, I have a countersunk hole. Again, it's going all the way through. I have a countersink diameter that is 0.4 at 82 degrees and a drill diameter of 0.27. Positioning. Distance from the back edge. Ooh, we don't know the distance from the back edge. We know the distance from here. 2.5 plus 1.78, and a distance in from the edge of 0.62. We're going to mirror both of these. Plane down the middle. I want to mirror a feature. I want to mirror countersunk and the counterbored hole on this plane. Done. Hide the plane. Material is not specified. We'll stick with steel.